Doug Neal, broadcasting live from Case Western Reserve University. Woo! So we're doing a hybrid meetup here in Nord Hall, courtesy of Case Western Reserve and the Computer Science Department. So thank you very much. And so the agenda today is we're going to have a 10-minute talk on what's happening at Case Western Reserve Computer Science from Professor Vipin Chowdhury, who's the head of the department, and then we're going to have 3 20-minute talks from Snowflake, Google, and Dremio, and then yeah, that's the agenda today. A few announcements. Again, the member approval process. I still have to approve members. Again, we had some drive-by spam. It was kind of bad about 1.5 years ago. I had to institute this. Used to be you didn't have to get approved. Don't worry if it doesn't happen immediately. I'll do it probably within the next 24 to 48 hours. But I do approve most of them. Sometimes I do check just to make sure there's real people behind them. But again, I'm approving most of them. So if I do hit you up with a question, please answer that on Meetup. Also, again, the friends of the show. So the honorific that you get after doing a Cleveland Big Data Talk, if you become a friend of the show. Again, it's a lifetime honorarium. You cannot gift it or will it to your children, but you do keep it for life. So, again, if you're interested in becoming a friend of the show, please let me know. I'm always happy to have a new speaker, or if you know somebody, or if there's some topics that you would like to see presented, please hit me up. There were 2 community announcements that I saw. Cleveland Water Alliance had pinged me and wanted to announce something. Also, I saw the NASA Space Apps Challenge was coming up. So if there's somebody on the meetup from the Cleveland Water Alliance, if they could put in the chat and I can announce it, I'm going to give it a second. Oh, thanks. I didn't realize that the volume wasn't great. Hopefully it's okay now. And then the NASA Space Apps Challenge, again, I'll send out some links on that in the email. So it looks like there's nobody on from the Cleveland Water Alliance. So I'll have to get back to you on that. And again, we are planning on having a November meetup. So we're working on the agenda and stay posted on that. So once again, as always, thanks to Chris Barrett, the co-organizer, Linux Foundation, and John Murdoch. We could not do it without you. And thanks again to the members and attendees of Cleveland Big Data, because you are what you guys make this meetup possible. So so Tomer, I see your email. I'm gonna have to get back to you on that. So I think we're going to move on now with our first presentation from Vipin on Case Western Reserve and the Computer Science Department. Take it away.
Right. Can we go to local laptop, Mike? Because they're still hearing it.
Yeah, I'm going to try this here. Okay, can you hear me any better? Anyone? Better.
I'm seeing better. I think
Okay.
you can say better in the.
Okay, let me try a few more things. Okay, maybe this will work better. So. Well, first of all, thank you, Doug, for getting this meetup to Case. Hopefully, we can increase the participation in person as we go on. So I'm going to talk about the Department of Computer and Data Sciences. So just a quick glance, and a lot of you are already aware of a lot of this about Case. But we are one of the top 20 private institutions in the country with about somewhere between 5,000 to 6,000 students, undergraduate students. We are a well-known science and engineering university with 17 Nobel laureates. We are a member of the Association of American Universities, which I believe is about 60 to 70 universities. Pretty good research revenues, and our students, they rank in the 98th percentile nationally. So let me talk about the department. So the department was spun off from the EECS department a couple of years ago into ECSE, which is Electrical, Computer and System Engineering, and Computer and Data Sciences. So they took computer science portion, added data science to it. And I think we might be one of the first, or at least I don't know of any other department in the country which has computer and data science together. We have master's and PhD program in computer science. We are fairly small as a department currently, with 16 faculty members. Our enrollments are approximately 170 graduate students, 60 of which are PhD students. And we offer BS and BA in computer science and BS in data science. And we'll have graduate degrees in data science pretty soon. We are about 600 students, undergraduate students, and we are currently the largest department in the university. I think we comprise little over 10% of the university undergraduate population. And this is no surprise. That's the case in almost every university. Some interesting updates. Since 2017, our student population has grown by 30% in the department. Our faculty recently has been winning a lot of awards. Prominent among them is the NSF Career Award. This year, Dr. Zushen Zhao, he got the NSF Career Award. And this is an award which sort of marks you as a superstar down the road. We've been doing very well in research funding. We are up about 4 times that of last year. So, excellent year for us. And this was also possible because we started collaborating a lot with many institutions. I mean, of 16 faculty that we have collaborations with over 100 external institutions and also over 20 departments across the university. And we are on a path of growth. So we are hiring 4 faculty this year. So that is about 25% increase. And we hope to continue doing that. Some of the research areas, I mean, we tend to cover a lot of the standard computation and data related research areas: algorithms, theory, software engineering, AI, machine learning, data science, bioinformatics, modeling and computational science, computer networks, systems, big data and high performance computing, databases, data mining, security and privacy, and most recently we are delving into quantum computing. So this is the list of the faculty. I won't go through this. This is all available on our website, but you can see how the different faculty are interested in different areas. And some of the hiring that we are looking to do is in the area of AI and machine learning. So what are we looking for? Well, for those of you here locally, we are looking for instructors who love teaching, who like to interact with students. So instructors in either computer science or data science. We are also actively looking for PhD students. As I told you, we have quadrupled our research funding, so we are looking for lots of PhD students to do research. And certainly a lot of our students are looking for internships and jobs. Most of them go to one of the coasts, but if there are nice opportunities here, I think they would love to stay here, and I think we'll get some really excellent employees. And always, we are looking for sponsored research and certainly involvement in technology startups. So both from students and faculty and some of our graduate students as well. With that, I'm happy to take any questions if anyone has, or pass on to the next.
Okay. Again, we're looking at the chat now. If anybody has any other questions about the computer science department, please put them in. Give it a few more seconds.
In the spirit of in person, I'll ask it in person.
Yes.
How has the virtual era, you think, supposedly increased enrollment at Case in the computer science realm?
Actually, as a university itself, we've done pretty well during the COVID time. Our enrollment, this year is our biggest class ever. Computer science globally has been doing excellent, so no surprise there. I think the productivity of faculty in some ways in research has gone up. We saw the numbers. So overall, it's been a terrific year. It's been tiring, sitting all day, but I think it's been interesting. Not being able to interact with students, especially the new students, that's tough. So trying to get someone into your group as a new person, that has been hard. But existing researchers continue to be strong.
What have been some of the other challenges about managing a comparatively larger group of students? Like, can you still provide the same amount of attention to the increased computer science student body?
Well, in general, our class sizes have gone up because students, number of students has just gone up, and that's why we are trying to increase the number of faculty and also the opportunity that exists in Cleveland at Case to collaborate with other units. Right? Everyone wants to do machine learning, data science, and actually the pressure on us, we can't help everyone. So the pull is tremendous, and so yeah, I think it's probably golden time for computer scientists and data scientists and that.
And you want to read off these?
Yeah.
I think they came to actually Bob was typing there in the chat. They're worth noting.
So incoming total freshman class 31,000. Oh yeah, yeah, that's right. So 1,600 students have arrived, and last year it was 1,250. So you can see there's a tremendous increase. Thanks, Bob.
Awesome. So with that, thank you for the live clap. Hope you'll get a few virtual claps from our audience. And with that, we will go to our next speaker. I believe.
Should I unmute? How's the volume? If maybe I could get started. You there? All right, can everyone hear me? If I could get some feedback in the chat, it's probably the idea.
I don't see you sharing anything yet.
Little feedback, okay. First, is that better? Maybe I just have the mic too far away from me. Cool, and I would be. All right, hopefully everyone can see.
Oh, there you go. Whenever you're ready.
All right. Start it off. There you go. All right, so my name is Volkan Mesko. I am working in sales at Snowflake. I am definitely an avid nerd that likes to be evangelical about technology these days. I've really soaked up this stuff and all the stories. So here's what I want to present to you guys today. So the future of secure data sharing is really the title, but I'm willing to argue that here, it is the future is today. So this is my argument to you. For those of you who haven't heard about Snowflake, the company, we went public last year in September, actually coming up on our 1-year anniversary. Before, when we were private, with Forbes had us ranked in the Cloud 100 on the 2020 list. 3,500 employees. We're actually hiring 1,000 this year, so hopefully some from Case Western. Okay. Our presence is now in 10 out of the 10 Fortune 10 companies, so it's very vast. We've now eclipsed the 40% mark on the Fortune 500 company, where they have a footprint within Snowflake. Our NPS score, if you guys have ever heard of the Net Promoter Score, kind of like how people tend to recommend just products in general. So you think of 71 is actually almost 4 times the industry standard in technology. So Apple being at a 47, 71 would be in retail like a Costco. So think about how you recommend Costco maybe to friends because of their return policy. That's how evangelical people tend to be about Snowflake. We also crossed the 5,000 customer mark where we've been selling Snowflake daily at scale since 2018. So it's pretty phenomenal to have this enterprise footprint at this point. Now, for those of you who don't recognize this guy, Warren Buffett is an avid pre-IPO investor in Snowflake. The only other pre-IPO company he's invested in, and this is by far the greatest data point for me, he invested in Ford pre-IPO in 1957, and then in 2020 at Snowflake. It's pretty cool to see that. So where we dabble is, of course, unifying data. I don't know why only 87% of decision makers want to expand their ability to centralize data and to use external data, but this is our mission. And McKinsey did a study on this in 2015, where they aggregated the uplift in global GDP. And this is a conservative number, right? If data was centralized within an organization, if it was shareable to an instantaneous level, we'd have an uptick of $3 trillion. And I think they've adjusted those numbers since then to $5 trillion. So this is my argument for today, right? So data sharing today is very cumbersome, very fragile, very manual driven, right? You're checking data through APIs, standing up FTP servers, data is delayed, and most importantly, once data is moved, it's gone. You can only enforce it through a legal document. Who knows what happens after that? Right, that's the problem. So of course, lo and behold, I'm introducing the Snowflake Data Cloud, but I like to dive into beyond the marketing aspect of it. Right, so I like to break it down into 3 things for a social network to happen. You got to have the platform or the technology. You got to have the people, who's in the network, and you have to have the content, right? So leading off the technology, right? The architecture for Snowflake was built from day one for the cloud. We separated storage and compute. This is nothing novel today, but what is novel is separating compute from compute. So you're isolating all these workloads that never step on each other's toes as they point to a single source of truth, right? Or consumption-based, you only pay for what you use, and the cloud services layer is magic to it all. We have over 100 granted patents that manage all these clusters up and down in milliseconds, right? That is something to keep in mind. That's where all the magic happens, where I'm about to tell you. So we're not just a centralized data warehouse anymore. That was our story back in 2016, 2017. We dabbled in the data lake space, the data engineering space, right? You no longer have to have your data inside of Snowflake. You can reach outside of it. Right? You can grab all that metadata and just compute all that data. Now we can deploy data applications on it. But really what I'm here to talk to you about is the data sharing aspect. This is why Snowflake today is trading at 100x its revenue, which to some people would boggle your mind, but maybe it doesn't boggle your mind after kind of the stats that I'm going to go through. So 18 to 24 months ago, we were completely isolated to the cloud and region we were deploying in. And something I didn't mention is that we're cloud agnostic, right? So we deploy across AWS, Azure, or GCP, doesn't matter. Now, we thought of this whole, cloud services layer and built in cross-region and cross-cloud replication for high availability and disaster recovery, but also not as a byproduct. This was the main product of it, is to unify the whole system globally across cloud, across region, to eliminate ETL and data movement, right? So Snowflake becomes data sharing through access control. There is no data movement, and with the utmost governance and security built into it, right? So you could be in AWS and Azure, you wouldn't know. It's still Snowflake, and if we were having a beer right now, I'd tell you Snowflake is just one big database. Try to use some different choice words, but anyway. So data sharing, what it comes down to, I kind of bolded the, so it's live data, right? Only pointing to a single source of truth, ready to query. There's no ETL, no movement, cross cloud, cross region, and it's governed and it's revocable access. So now I no longer need to just rely on the legal team to protect me. I can actually enforce what I'm sharing. So if we part ways as two businesses, two partners, I can take all that data away from you, and no one's told us that. So today, really, this is what it comes down to. It's a direct share, right? I'm sharing, let's say, to Doug's Snowflake account, and he's sharing to me. Now, if Doug doesn't happen to be a Snowflake customer, we have reader accounts. And the latest technology coming out for us is that now reader accounts can also become writer accounts. So the network expands exponentially, and I'll go through that. So second point, who's in the network? This is from our July 31st numbers. It's a highlight. 212, over 40% of Fortune 500 customers are now Snowflake customers. Companies are Snowflake customers, right? We actually have a line of sight to 2/3 of the Fortune 500 right now within 12 months. So the network is growing. And this is a node link diagram where you see the relationships of companies sharing data with one another. So each dot cannot exist on this graph if they haven't been sharing data through a stable edge, or what we consider a 6-week or more data share, a direct share. This is cross-cloud, cross-region. Everyone's in the diagram here, right? This is what it's proliferated to since April 2020, right? So it's grown staggeringly. And I'll even put some numbers to it, right? So the provider side, there's 1,881 providers. I ran this report today again. I had an uptick of 34 providers come up from last week when I ran it on Monday. And then the consumer side, 3,800 companies are now consuming data in an instantaneous fashion, right? There's no ETL behind it. So this is us in financial services. I would argue at this point, most major insurance companies are either running or migrating to Snowflake. Retail and CPG, even in Ohio at this point, Columbus kind of dominates the market in Ohio and retail. Most of those companies are now migrating or on Snowflake, right? In media, we have pretty crazy logos and NBC and Mickey Mouse logo and all those big brands. Healthcare is becoming real big because of ETL and healthcare does, it's called interoperability. So that's becoming big for us as we're in a couple dozen providers at this point. Life sciences as well. We just signed up the largest COVID tester in the world as a Snowflake customer because they actually needed live access to data of tens of terabytes. And then, of course, our friend Jim Cramer thinks 100% of the Fortune 500 companies will be Snowflake customers. And he's got a valid point here because it's a consumption-based model. So you're only paying for what you use. And quite honestly, Snowflake at the workload level can be quite cheap. And you can establish the ROI, right? Why not run this workload for $7 if you get a couple $1,000 value out of it, right? So then we get to the content, what we enable through the platform, right? You, within your company, can establish a private data exchange. So now you can publish your data as a product for everyone within the enterprise to access, again, with the utmost governance in mind, right? So marketing does a customer 360 thing where they're pulling in different data sets. Finance then hops on it. Why don't we start financing these people? Well, more corporate finance versus consumer finance. Other business units start sharing this data, and all the analysts can access it, right? It's instantaneous live access, again, to the single source of truth, right? Customers, partners, vendors. There's now SaaS companies, platforms on top of Snowflake, where you don't even need to move your first-party data anymore. They'll just put their algorithm right into your Snowflake account, right? And suppliers. And again, security, access control is number one important here. This is our publicly facing data marketplace. This is pretty big. We had 20 providers last year, 12 months ago. Now we have 180. We have a line of sight to 1,000 companies, data aggregators, data providers, right? The Equifaxes of the world, being on Snowflake today, ready to share data. So a couple highlights here, like Philips will share their homes under contract with you. So you know, as a marketing team, who to reach out to who's going to be moving into that home, right? This is crazy. Foot traffic in near real time for 30 million Americans because there's 300 applications on our phones today that we opt into to get tracked on telemetry data. So this is coming in near real time. Again, there's no FTP, there's no storage involved. It's just access control to that data provider account, right? Weather data, 1 petabyte of FTP, how is that even possible? Or API calls? With Snowflake, you have instantaneous access. Now, a petabyte of data equates to hour by hour weather back in the year 2000, right? That's $250,000 of savings in just storage alone. The audio is still a little rough.
Yep, yeah, let's play that.
Hey, Chris, good to see you. So Nielsen, Equifax, Adobe, BlackRock, all these companies and more are now platforming on top of Snowflake, so you can have your own curated personal data right back in your Snowflake account. So very ever expanding. All right, so I think we went through all three of them. I got a few minutes left. So who's actually doing this, right? Because I talked about the numbers, the 1,800 providers and 3,700 consumers of data. So a couple publicly facing case studies here. So Kraft Heinz has been published about actually establishing an end-to-end supply chain view. I don't know if any of you have studied the bullwhip effect, but that is about minimizing that. So next time you're in a grocery store, you probably won't find Heinz ketchup out of stock or Kraft mac and cheese because they're using Snowflake. But that's a joke. Don't hold me to it. But they have more efficient marketing because they're pulling all these data sets, these marketing data sets, including weather data, on how to segment better, how to build more audience, get it out there more often, with more volume, right? And then they're building plans for different distribution center allocations, where to build the next distribution center based off of all their models that they're running now at scale. Again, off of one single source of truth. There's a company who's a big networking company. Probably all of you have dealt with them or have heard of them. Not the chicken company or the food company, right? But there's 18 global component manufacturers that they have to deal with globally. And they have to FTP, or before Snowflake, they have to FTP hundreds of terabytes of data to the with the defect report. And they're like, this is insane. This is so manually inefficient. How can we do this better? So instantaneously, as the reports are coming in, they're getting the data share straight into these component manufacturers. So customer satisfaction goes up, and of course, manual efficiency goes through the roof. There's a company, Fortune 50, global, probably very recognizable brand. They have a concept of, Snowflake has a concept. We actually patented the data clean room. This is pretty much a party B, let's say a big company who's advertising, marketing, and wants to share data without letting party A, this big Fortune 50 company who has a ton of streaming services, know, hey, we want to advertise to our customer base here, and we want to see the Venn diagram of where we overlap without you ever finding out. Now, there's complex mathematics to do this, but with Snowflake data sharing, which is, again, a patented feature at this point, you see that without the heavy computational power. So super easy, secure, and very powerful. This is happening today. Now, Bayer has been vocal about their data shares with IQVIA. They've completely eliminated the removal of the ETLs. Now, IQVIA, to go into it, they have 35 petabytes of data shared through 10,000 data products. So that is predominantly shared with Bayer today. So now Bayer internally shares this to a broader audience, right? So that there's a group of analysts that wants to see this data instantaneously, they have full access to it. And more often, because the refreshers happen more often, right? They just show up in your Snowflake account every morning. So now they have a faster time to market in the drug space, in the pharma space. And then sales and marketing ability has gone up because now they know who stopped using the drug, competitor products have been picked up. How do we intersect that? How do we service that? So it's been huge value. They've been very, very outspoken on the business value created here through data sharing. Actually, one more, there's another pharma company based out of Europe. I actually got the privilege to talk to the chief data officer who has 300 data scientists under his helm. And he said he spends $50 million on third-party data, 60% of which is now shared through Snowflake, which is super powerful because the SLAs now that he's able to provide to his business are bar none. He can't go back. That's how much business value he's created through these data scientists, getting this data so fast into their hands. Now, Pizza Hut, funny enough, football has just kicked off. So this is a good story. They are going to, well, last Super Bowl, they already did this, but they run real-time reporting during the Super Bowl, and they send it to a data aggregator. Actually, they don't send it. The data aggregator just meets them halfway, sends their algorithm into their Snowflake account, and in real time, you'll get a ping on your Pizza Hut app, knowing, based on their inventory locally, like, hey, we have extra, Diet Coke 2 liters on sale. Here you go. You want to pick some up. So this has provided a huge lift to the business, and now they're deploying it at scale through many sports throughout the regular season, right? And they also utilize weather. They found the lift in that, and geolocation data, which again is fed in instantaneously. Petco's working on some major partnerships with food delivery services that you can probably imagine. And just in a nutshell, Snowflake, it works. It's the iPhone of data platforms. But really what I wanted to highlight here is that it's connected to the network and to what matters. So I think I got like 50 seconds left. I'm happy to take some questions. Sorry if the audio was rough, but I appreciate you guys listening in.
So any questions? Any questions on data sharing? How it works? Any other technical tidbits? Going once, going twice. We get thank you, Zoltan. A little round of applause here. Give Zoltan a virtual round of applause too. Next up is Google. So John, I think you were presenting for on the next one.
Yep, yeah, that's correct. Can you just confirm you guys can hear me up there?
Yep.
Perfect. Okay. All right. Sorry, I'm not as familiar with Zoom, so it may take me just a second here to get sharing going. Oh, Zoltan, looks like I need you to close your share screen there. There we go. Thank you.
Cool. So John, whenever you're ready.
Okay, can you see my screen now too?
Yep.
Perfect, perfect. All right, thanks everybody for coming out virtually and in person as well. Wish I could have made it up there today. It's amazing how much you kind of crave those in-person meetings after being locked up here for so long.
You're missing some good snacks up here.
Yeah. So my name's John Hurst. I'm a customer engineer for Google Cloud. I'm based just north of Cincinnati, but I cover most of the Columbus area, and as well as some of the Cleveland area customers as well. So I've been with Google about 3 years now, focused mostly in the data side. So what I wanted to talk to you today about was a big part of our data platform is BigQuery. It's kind of our crown jewel for enterprise data warehouses, lots of different use cases around that. And I just want to kind of focus there with what you can do with BigQuery, what it is, and then also some of the public data sets that we have, including a new one, and how that can really get you jump started into doing some trend analysis. Focus mostly from like a retailer perspective, but really could be used across multiple businesses. So just getting started with what BigQuery is, it's been around for a while. It was actually originally built for Google itself. As you know, Google is a data company, so really needed something that could handle the scale and complexity of everything that Google was doing, from YouTube and search, ads, all those different business units that Google runs. So they developed a petabyte scale storage and compute architecture that could handle all of that data and queries that they were running. So they wanted to then turn that into a product that also could be shared across anywhere in technology. So with this, it's a serverless architecture, meaning you have zero concern around the sizing requirements or zero provisioning or anything that needs done. It automatically scales across any amount of compute and storage that you would need. Can handle real-time insights in streaming data, also in batch data. So there's really no limitation there in terms of how you can get the data ingested into the system. And then there's also built-in machine learning into the platform with bqml. And then also I'm going to talk briefly about a couple other machine learning patterns that are also heavily integrated, but just sit just outside of BigQuery itself. So I talked a little bit about the architecture. The storage is designed for 10 nines of durability. So you don't have to worry about not only the scale and the size of your storage that you need, but also to know that you're not going to lose data. And then with the separating of compute and storage, we have the highly available clustering for compute known as Dremel. So this again works very similarly. It's serverless in the aspect that you literally don't have to worry about what amount of compute you need, how much compute. Any query that's running there will be handled and scaled appropriately. So just a little bit about how BigQuery is differentiated and what it does from a traditional data warehouse, speaking more to the legacy, like on-prem data warehouses and things like that. You can really see it just migrates all of the time over to you being able to do what you need to run your business. So rather than worrying about resource provisioning, the scale and the monitoring of those resources, you're just focused on the analytics and the insights you can gain from that. And it's also, as a service itself, is 99.9%, 99% SLA. So that comes out to a 4.3 minute SLA of unavailable time. So you can also see, compared to our top 3 competitors in the space, they're just 1.9 of SLA. So you go from 4.3 minutes up to 43 minutes of potential downtime. There's zero extra charge on this. It's not like a scaled support level. It's just how the service was designed and how we deliver it. So the other piece of this that I wanted to talk about was our public data sets that we have. They're globally shared. We started them in 2016. Today we have 187 various public data sets, and even within those, they break out into individual databases and tables that you can break down. So You can really slice and dice a lot of different things inside of that 187 to get to what you're wanting to see. 164,000 queries per day on average, 2.8 exabytes scanned since the program launch. That's probably not even accurate considering I pulled this like this morning, so that's probably even higher now. So again, it shows kind of the scalability and flexibility of BigQuery and Google Cloud, and also how the data sets that we provide free as a service are leveraged across multiple customers. One new one I really want to focus on is our Google Trends public data set. We just launched this a couple months ago. So Google Trends as a data source as a whole has been around for a long time. If you go to trends.google.com, you can see the most recent trends that are out there and even search and filter inside of the user interface. It's a great tool to use and just get some quick information on. What we did was we took the top 25 stories and 25 rising terms in every DMA, all 210 DMAs that are based on the Nielsen DMA design and categories. And we put those into a table so you can get access to them at any time. So the storage and everything, every part of that data as it's hosted is completely free to every user. You only pay for anything that you query. So since the entire cost mechanism around BigQuery is based on consumption, you're only paying for data that you query. So even if, any where statement or anything like that, it limits it down to the size. You're not querying the entire data set every time. And it's refreshed daily with new terms. So there's a lot of different pieces in here you can see, and you can analyze based on just what has been searched, where those searches rank across multiple DMAs over the 5 years. And I can show a bit of that as well, and kind of how that relates to more of a simulated sort of use case for a retailer. As I mentioned, the Google Trends data that's been out there in a UI for a long time. That's what you see here on your left-hand side. It just gives, again, kind of a user interface. You can see the topics, you can look at terms, you can search. What we've done is taken that top 25, like I've said, per day, per DMA, and put those into tables inside of BigQuery to be queried. And you can see the different, personas that may get value out of that, marketing, merchandising, demand forecasting, supply chain, executives. There's really an unlimited number of use cases that could come out of that. So the next phase of this that we're in development right now, we will be launching soon, it's a full data signals UI. And what this is it gives you a custom list of terms that you can create. So we're not just limiting it to the top 25 of either terms that were, ranked by DMA or in the rising terms. This is any term you want. So it could be ranked, 4,897 and of that given week or whatever, and you still get to keep your 5 years of historical data around that term. So it really opens it up to any specific use case you may have in different industries. So you're not just seeing what's top right now. You can actually build some analytics around, different things that have gone in, like COVID-19 as a search term in, August 2019 wouldn't have ranked very high at all. But then you go to February 2020, it's going to be at the top of the list. So you can get a lot of those insights just from looking into this data. Specifically around trend analysis is really kind of where I'm pointing this as the use case. And you can see here in the, schema design I have for the top trends data model, we list out the different terms, the DMA ID, and those sorts of things. We also give a % gain in there as well. When we release the custom terms modeling, it'll have a score, a different score in there as well. And we're working on getting more predictive analytics around that to actually show what we think it'll be 3 weeks out from now. So again, that's all coming in the future release of data signals. This I just wanted to throw up. It's a very simplistic kind of use case of how a retailer might use this data. And again, this is one of the many public data sets that Google Cloud has on BigQuery. So if you just look simply at a map of maybe in the upper left here where you have stores or locations, and you can see your sales data kind of across the bottom. That gets you a certain level of information that's, every company uses that to see where their sales are. Well, if you actually narrow that down inside of, a specific DMA like Evansville, Indiana, and this is just for this past week, what were the top 13 search terms in that ranking there? So, let's say this is a athletic wear company, or a NFL licensing, given the terms that have come up in this past week, they would learn a lot in terms of how to, join this level of data into their sales and see how Google search terms were actively engaging with their customers and affecting their sales going forward. So if you take,
10 minutes left.
okay, thank you. So if you take that kind of a step further and you start getting into machine learning, how can we do more trend analysis? How can we gain more insights from that to start predicting what's going to happen rather than just reacting to it and seeing a historical approach? So another managed service we have that sits outside of BigQuery is AutoML. So with AutoML tables, we have a lot of built-in algorithms. So it's not, when you hear the term machine learning, can be very daunting for a lot of users, whether you're technical or not, it can still be a daunting task. So we have a lot of pre-built algorithms that you can use just straight out of the box. And literally what you're doing is you're just looking at raw tabular data in this case, and even taking what I showed before in the Google Trends data, just, pulling in a query of that. Again, this is all tabular data. And you can get, from our pre-built algorithms that we have, this is just a small list, demand forecasting, price optimization, customer lifetime value. When you start pulling in multiple data sets and getting a different aspect and a different view of the data that you have already at your fingertips, you can make a lot better business decisions and drive your business in a direction from this predictability that we can provide. So another thing we have directly inside of BigQuery is bqml. The big benefit here is you can kind of see on the left is it's running through, a little bit of a demo of what this looks like. It's literally writing SQL as a model, and you can iterate on that model inside of BigQuery. It's, again, doesn't take a drastic amount of education outside of SQL to be able to run these. And you can automate a lot of the tasks. So in terms of deployment of the model and versioning of the model, you can do all that right inside of BigQuery in the same engine where you are doing just your base analytics, writing a SQL command. So the next piece, and this is really the final piece I want to talk about here. So where this is leading for us as well is getting into not only a place where we can share data in these public data sets that we have, but also allow other customers to share this and open that up in what we call Analytics Hub. So today you're able to do this. You can share data, from customer to customer or individual to an individual, but it requires some interaction personally to go through and reach out to that company or that individual and ask for that. And then the security can be granted to securely share that data over to you in that data set. However, we're building a hub around that to make this process a lot easier and simpler for everyone. And again, so this will go around the same aspect as any marketplace that we have for like our Google Cloud workloads and software vendors and things like that. And you can see here, it just gives a different view to where we have today, like our public data sets, and they have private, commercialized so that they can be monetized. Google first party data sets will be in there as well. And really there's just a publisher project where you're storing that data. So you pay for the storage, and then the user of the subscriber in this case will pay for any compute they use to query against that data. And again, on the far bottom right there, you can see we have direct integrations with the top BI platforms. So that way it can even get a better user interface for any of your users going forward. So this gives a little bit, just a different, like kind of clearer picture of that. So, and again, like I said, this image on the left-hand side, you can do this all today, just by using IAM permissioning inside of Google Cloud to allow access into specific tables or the data sets that you have. What we're doing is in the numbers 1, 2, and 3 areas, we're automating the process for any updates, any security that you would implement with that. We're automating that entire process for you, so you don't have to worry about writing anything to get that done manually. And again, like I said, so the data publishers will pay for their storage of that data, and the data subscribers will just use that consumption-based model for any queries they run against the data. So just big picture, what I really want to get across from this is the why for BigQuery. There's zero infrastructure to provision and plan for and monitor and all those things. It's very simple to use. It's ANSI SQL 2011 compliant. So your typical SQL queries that even business users and analysts run today, and continue to run on BigQuery. And it's very open. We're sharing 187 public data sets today. That number will continue to grow. And with the implementation of Analytics Hub, it'll open that up even further. So there'll be a marketplace in front of that, so you can get to any other data sets that you may want to access that we're not offering today. And that's all I got. So sorry, I talk kind of fast, but hopefully it all came through there.
No, it's all good, John. Thank you. There's like 3 minutes left. So if folks have some questions, there's still some time. So what, John, I've got a question. On the machine learning within the query engine, what functionality is it comparable to? In terms of pandas or scikit-learn, like how similar are the verbs functionality you have access to?
Yeah, it definitely has a lower functionality to what you would get in Scikit or Pandas, which it's kind of the, if we have sort of a phased approach, look at it in terms of the, you could say less functional to most functional being, most functional being like your own custom TensorFlow modeling, on your own VMs running containers, and this is the kind of the other complete other side of that, where it's literally built for more of the simple approaches to have a model out there, and it can be accessed via API, so you can return results against that model. The idea here is just that you can have the a business user, someone that's more understanding of SQL, that can get in there as well. So it's not just limited like to a data scientist to be able to do machine learning and to do modeling. Hopefully that makes sense.
Okay, thank you.
Yep.
Are there any other questions? Okay, here we go. John, do individual public data sets get updated over time?
Yes, they do. So depending on the data set, it will, like the Google Trends data, like I said, is updated daily. We also have weather data from the NOAA. And we have, we actually have some sports data sets in there as well. So it just depends on the actual data that's there that can be updated, but it all gets updated automatically by their provider behind the scenes. So there's nothing you have to do in order to keep up to date with it.
Cool. And one other question here. Are there any advantages of using BigQuery with Data Studio compared to other BI tools?
Well, I would say the biggest advantage is Data Studio is free. So if you're just wanting to create some BI tools, just to kind of give a fresher look to the data and get it in more of a cleaner view for your business users, that's the easiest and quickest way to do it. Again, it doesn't require anything to be provisioned. It just runs, it connects straight over to your queries, very simple to use.
Cool. And I think we're at time now. So John, thank you very much. Everybody give them a real or virtual round of applause.
Yeah, thank you. Thank you. Appreciate the time.
Thank you. So we're working through a few technical issues at the moment with our third speaker. So hang on, folks. We are give us a minute or two here. We're working through an issue. And we're going to try, Tomer, if you're on the call, we're going to try resending the speaker link. So we're working it here in the back end.
There you go. Can you hear me?
Oh, there you go. Hooray!
All right. You did something that gave me this promotion thing in Zoom.
Oh my God, I was terrified. I hate letting my presenters down. So I'm glad this worked out.
All right. So we figured it out. Okay. Well, good. Let me share my screen then here, and we can get going.
Well, actually, so John Wernick, thank you, from the Linux Foundation. He's the one that had the magic hand. Yeah, thank you, John.
John saved the day. All right. Cool. So yeah, my name is Tomer. I'm one of the founders of Dremio, and let me share my screen here. Actually, share the desktop so we can do a quick demo too. All right, so let's get started. So the top. What is it?
Oh, no, it looks good. I just wanted to confirm.
Oh, okay, cool. So the topic of my session here is the SQL Lake House, and I'll talk about what we're doing to really enable an open data architecture. One of the things that we really believe in is kind of avoiding that vendor lock-in, owning your own data, not having to, put it in someone else's service or environment. And so that's what this presentation will be about. You see my contact information here at the bottom. Feel free to reach out. So what we've done at Dremio is really enable companies to run very fast SQL and BI directly on data lake storage. So if you're using something like S3 or Azure Storage or Google Cloud Storage, we allow you to run queries and get very fast BI dashboards, sub-second response times, and so forth directly on storage. And that eliminates the need for proprietary and expensive data warehouses. The company has grown a lot. We're a unicorn. We've more than doubled the number of customers and our revenue every year in the history of the company, and we continue to grow very, very fast. And we also invest a lot in the open source community. So you may have heard of projects such as Apache Arrow, which actually I think is used in many different systems, over 20 million downloads a month. That's a project that we actually created at Dremio. And then Project Nessie more recently is a new project that enables kind of a Git experience for data, where you can create branches and merge things and have version control on your data, specifically on your data lake. We're also the hosts of the Subsurface Conference. So every 6 months we run this conference. Around 10,000 people come, and you have presentations from a variety of companies and open source innovators, startup founders in the world of data. Also, like the previous companies, a lot of enterprises use Dremio. 3 of the Fortune 3 use it, and I will not be telling you to take the advice of Jim Cramer. Don't follow his advice. So data teams are being asked to do the impossible. That's kind of the challenge in the market that every company faces, right? You have a lot of data. You really want to put it in the hands of everybody, of course, with all the security and governance requirements. And you would think that would be getting easier, right? We have new technology, new innovation, clouds, etc. And that should be easier. But in fact, it's getting harder by the day because the amount of data and also the demand for data, how many people want access, that's been growing much faster than anything else. And so what typically ends up happening in most companies is you end up with a picture like this. You have data kind of being ingested into cloud data lake storage. This is kind of your object store if it's in the cloud. something like an S3, and then you start ETLing it. You have to move that data into something like Snowflake or Redshift, right? It's not born there. It's actually born in cloud storage, and you start moving it. And then that's not fast enough, so you end up creating extracts in your BI tools. You create lots of copies within the data warehouse. You create cubes if you want to slice and dice the data. So at the end of this, you have this really complicated web of kind of ETL that's happening that nobody talks about, right? We all imagine the day where we have everything in very tightly organized in one data warehouse, and it just works, right? And of course, anybody who's worked at any real size company knows that that's not what the picture usually ends up looking like, right? And the result of this is that it takes weeks or months for analysts to get a response to their request, right? If they want to, look at change a dashboard, change the data sets, it's a long wait because it's an engineering project every time you want to do something. And of course, it's very, very expensive. So anybody who's used a data warehouse knows that the costs are astronomical, right? Even in the cloud with consumption-based pricing, right? It seems cheap when you're starting in year one. At the end of year one, you're like, oh, what did I do? And so we really advocate this no copy architecture, right? Enabling you to do your analytics directly on cloud data lake storage, to own your own data, and to get the performance that you need through a variety of technology innovations and patent pending technology that we've created around query acceleration to really be able to get that really fast performance that you need, so that you're not having to move the data into a warehouse, that you're not having to create BI extracts and all the pain that comes with all that ETL and managing all these different copies and extracts. When I talk about open data architecture, what I really mean is this, right? It's going from a world in which every system, every engine that you're using to analyze data, whether it's one data warehouse that's used in part of the business, a different data warehouse that's maybe used in a different part of the business, it's different data science tools, each have their own proprietary data, right? And that's kind of the traditional world, right? You might have separation of compute and storage, but you don't have separation of compute and data, right? The data is very much tied to one single engine. And the result of that is that you can only take advantage of what's in that single engine, right? So if there's some functionality that's not available within that engine, you actually can't run that on the data. And then of course, you're really locked in. It's very hard to adopt any kind of innovation that happens in the future, right? And we've all seen this, of course, in the past with Gen 1 systems, Teradata, Oracle, and so forth, right? So what is vendor lock-in? I think everybody knows. The new world and where the industry is moving towards is one in which the data is its own tier, right? The data is separate from the compute, and it's stored in open source formats like Apache Iceberg and Delta Lake and Parquet files underneath the hood, and that allows you to use a variety of different engines and technologies on the same data. And not just today, but even in the future when new things are created, because a lot of what we use today didn't exist 5 years ago or 10 years ago. And so you can only imagine what will be 5 years from now or 10 years from now. And so that ability to bring all this new innovation that's happening in the industry and just point it at your data and be able to take advantage of that is very, very compelling. And that's why basically every company, I'd say probably 100% of the Fortune 500 have a data lake in place, or a cloud data lake, or in the process of creating one. One of the things that I wanted to point out before kind of jumping into a demo is that we also now have Dremio Cloud. So we actually offer Dremio both as software as well as a SaaS service. And what we've done with a SaaS service is we've taken the query acceleration and our self-service semantic layer and our kind of unique integration with the key BI tools, and we've combined that with this kind of infinite scale and workload isolation in our cloud service. So you don't have to worry about how much capacity you have. Can you handle 1,000 queries at the same time? And also, of course, if no queries are running, you don't want to be paying anything, right? So you have that ability to enjoy the best of kind of both worlds, scale up and scale down. And then we've done it in a way that provides a single global control plane. So you don't have to worry about, okay, how do you provide permissions on data that's in different regions in the cloud as well. So let me jump into a quick demo here just to give you a sense of what Dremio looks like. And so I'll use the cloud service for this, but it looks very, very similar. Even if you're running it yourself. And so what you can see here as I'm logged in, as I'm looking at the data, and so I have connected to a number of different data lake sources. You can see I have some S3 sources here. I can also connect to other data lakes, whether it's Azure storage, my on-prem data lakes, and so forth. We also support connecting to other sources. So if you look at the bottom left here, if you wanted to do joins across, say what you have in S3 with your Oracle database, yeah, you're able to do that as well. And then here at the top left, you can see this is our semantic layer. So this is where you can define different views of the data in a very business-friendly way, and then expose them to different BI users. And you can use kind of provide fine-grained access control and using different roles to decide who gets to see what view of the data. So as a very, very simple example, I'm going to open up this data set here of New York City taxi trips. And this is a data set of just over 1 billion records. So every record here is a taxi trip in New York. You can see the vendor ID, the pickup time, the drop-off time, number of passengers. And I'm going to click this Tableau button. So we have this unique integration with Tableau where you just click a button in Dremio and opens up Tableau, and vice versa. If you were in Tableau, you could very easily connect to Dremio with kind of full integration, single sign-on. So in this case, we within Dremio, we use Google. So that's what I'm using to log in. So I can start now playing with this data. So let's say I wanted to look at, right now I'm in Tableau. So Tableau is basically, I'm interacting with a BI tool. It's sending SQL queries and providing that kind of sub-second response time. So I'm looking at the total number of records is 1 billion. And let's say I wanted to group this by time. So look at it, how is this changing over time? So you can see the number of taxi trips per year is 170 billion. And maybe I want to look at the, what is the average tip amount?
It's over, the window that we see is a Tableau window right now. So Tableau created this window to authenticate.
Are you seeing the Tableau window or you're not?
I'm
Oh, you're not.
It just says, yeah, Tableau.
Oh, sorry about that. Okay. Sorry about that. So yeah, I had opened up. So once I clicked the Tableau button, Tableau opened up and I was just interacting with the data. So I was dragging stuff here. So clicking on average here, and you can see that, you know, the average tip amount, and I'll do some more interactions just to show you kind of that speed that you can expect here. So you can see here, if I'm looking at it by week number, so the average number of trips, and you can look at the average tip amount has gone up pretty consistently. So you might wonder, well, why are tip amounts going up? So you can look at the total amount, let's say, and see if it's just a factor. It's just that tips are a percentage of the overall fare has gone up, maybe. But you can see that hasn't gone up as much. So that's kind of interesting. And maybe I want to look at the trip distance, right, in miles. So I can drag that here. And you can see all these queries coming in from Tableau and getting that kind of very interactive response time that a BI user expects. And we can do this without having to move the data into a data warehouse and without having to create, Tableau extracts in this case, and do all that engineering work to provide this kind of speed. Now, I can also go back here. If I go back to my the Dremio user interface, I was here. Let's say I wanted to, actually, let's create another space here just for this demo. So I don't, so I'm going to create a space called Meetup, and you can see here the permission. So I'm just going to leave it open. So you can see there's a new space here called Meetup. You can pin it to the top. Now, let's say I wanted to look at the trip distance in miles and say, you know what, let's look at that in kilometers. So I can multiply the miles by 1.6, change it to kilometers. I'm going to keep the original here. And now I have a new data set with the trip distance in kilometers right after the miles. And I'm going to go save that in the space that we created, the Meetup space. So we'll call that trips KM. And now we have a new data set called meetup.tripskm. It's what we call a virtual data set, basically a view. If you know SQL, you can do all that interaction that I just did with SQL. At the end of the day, all I did was create a new projection here, trip distance in miles times 1.6, and alias that, right? But if I go back to Tableau now and go back to the data source tab here, what you'll find is, let me search for the Meetup because there's a lot of spaces here, is that the Meetup space exists in Tableau as basically a schema. And within that, I can see this table that was this virtual data set, this view that was created, trips KM. And if I drag that here, I can now start interacting with the trip distance in kilometers, which is this new column that was created. And you can see that even though we haven't done anything to optimize this data set, I'm getting that same kind of response time on this trip distance in kilometers, right? So I can create all these different views of the data for different users without having to create copies of the data, without having to maintain all these different pipelines. And you can actually see the graph and see that this was kind of based off of this other one. You can see in this case, the source is S3. That's the S3 S3 icon, but I can start to understand the relationship between all the different data sets in the system as well by just looking at this graph. Just before we wrap here, so hopefully that gives you a sense of what's possible with Dremio. I didn't show you how to join that, say, with another source, but we also have, for example, weather data in Postgres. So if I wanted to join that with my data in S3 of taxi trips, I can do some analysis and see, why are taxi trips shorter when it's hot outside and things like that. So to summarize, hopefully this gives you a sense of also how Dremio is different from not just data warehouses, right? The fact that you're not having to lock your data into a proprietary system, one proprietary system, but giving yourself the ability to use different engines, but also the difference between Dremio and kind of traditional SQL engines. And so it starts with that ability to have this very fast performance, which is a result of a number of different innovations, like our columnar cloud cache C3, where we use the NVMe cache on the AWS instances or the Azure instances to give you that really high access speed to the storage. All of that is transparent to the users. We have some technology called data reflections, which provide much faster performance query speed for BI workloads. And then as the creators of Apache Arrow and Arrow Flight, which is a replacement for ODBC and JDBC, we can provide much faster response time to the client as well. And so we partner very closely with the key BI vendors. That's Tableau, Power BI, Looker, as well as others. This is a blog post from the head of Power BI talking about how we're together enabling this kind of BI experience for cloud data lakes. And then the semantic layer, which you saw as well when I created that new data set with the calculated field, the trip distance in kilometers, just how easy it is to kind of provision different views of the data to different users, whether that's for business reasons to create different KPIs, or it's for security reasons. Really having that semantic layer where all the acceleration technology applies even as you're creating these new views of the data, you're still enjoying that kind of performance. And then the multi-engine architecture. So this is the ability to have different engines running in parallel, so you can isolate the workload of the CEO's dashboards from the data science queries that are running, and not have to worry about kind of any interference between them. And you can also see how much each team is using. And then finally, things that were previously not possible in these data lakes, right? That's the reason this is, some people are using the term Lakehouse now, is that ability to do transactions and to really have much higher scale, right? And not have to worry as much about how you organize the data in the lake. And then with Project Nessie, which I'm not going to have enough time to talk about today, we're really creating a world in which you can start thinking about your data the way you think about your code. You put it in GitHub, and you collaborate, you create branches, and you have kind of transactions across all of the work that you're doing. So we're bringing that to the world of data as well with Project Nessie, which you can check out. So that's all I wanted to share here today in this short 20-minute session, but feel free to reach out, firstname@dremio.com.
Thank you, Tomer. That was terrific. Also, kudos to anybody that does a live demo. That is really hard. So again, thank you so much. That was terrific. Any questions for Tomer? We've got 3 minutes here, plenty of time. Any questions on any of the terminology or projects that were in the presentation? So complimenting Jeff. Thank you, Jeff. Tomer, I've got a question on Iceberg. Was that the improvement? Was that the overall of the metadata store, or am I confusing that with a different project?
So Apache Iceberg is a table format. It was actually a project initiated by Netflix, although it has a lot of contributions from other companies like Apple and Expedia and others, right? Many of which use Dremio as well, but others that don't too. And what Iceberg provides is a table format. So if you think about in the past data lakes, you kind of had a bunch of files, and then you had a meta store that was separate from that. Iceberg really kind of managed tables in a transactional way. So there's like a manifest file that points at your Parquet files and allows you them to evolve kind of over time. So it gives you basically the ability to enjoy kind of the semantics of a data warehouse with your data lake without having to move the data into a data warehouse, right? You can have version control and insert updates and deletes, and also a lot of scale advantages as well. Partitions are hidden. There's a lot of ability to update your schema, update your partitions kind of instantaneously.
Awesome, thank you. A few more compliments rolling in. Thank you. So we've got another minute here. Any last questions? Going once, going twice. Again, Tomer's contact information is was in the presentation. Again, I want to thank Linux Foundation for supplying us with Zoom. Literally could not do this without you. Also want to give a thanks to Mr. Chowdhury from the Case Western Reserve University. So the three of us here, Golden, Victor, and myself, we're like a pirate radio station. We've got a conference room by ourselves. But this is incrementally, infinitely larger than any in-person meetup we've had in the last year and a half. We went from 0 to 3, so hopefully we'll get a few more in the coming, the coming months. But yeah, again, we were in the middle of the pandemic, so I get it. So yeah, again, if anybody has any topics you would be interested in, please hit me up. Either speaking or just the topic I'm applying to speaker for. So again, clap for everybody. Thank you so much for coming, and everybody have a good night and stay safe and backs up and mask up. Thank you.